Daniel's here, 2026 ASC from Wuxi. We're live. Well, no, not live, but we were live then. We're talking to Taiwan Tsing Hua University. I don't know if you know this, but your team, your school, was the very first school in the very first student cluster competition, man, in 2007 in Reno, Nevada, USA, where they had a power outage because the whole city of Reno didn't have enough power to handle the conference. Anyway, and your team has done really well in various cluster competitions ever since, becoming the first non-mainland Chinese team to win an ASC. So, good job. Let's meet you guys. So, introduce yourself, please. What's your name and what are you doing for the team?
Okay, my name is Lin Chenyu, and I mainly do the AMSS-NCKU application. It's a black hole simulation application.
Yeah.
And
not easy stuff. Not easy.
Yep. The physics behind it is very complicated, and I spend a lot of time reading papers about the black hole physics.
Really? Does that help?
I think it didn't help that much when optimizing the application, but it did help for me to understand the application better.
Yeah, no, that makes sense. That was good. Good job. So who's this?
My name is Pindi Huang, and
Hi.
I used to optimize the black hole program, but ever since the QiboTN problem dropped, I have been optimizing Qibo.
Okay, how is that going?
I would say we have achieved decent amount of optimizations, but it's mainly from the back end.
Okay.
Changing the back end code instead of having to change like compile options or flags like we used to.
Yeah, it's more than that then.
Yeah.
More complex.
Yeah.
What kind of a speed up are you getting?
It's around 5 to 10%. It's relatively limited, but I think it's
a starting place.
Yeah.
You might see something down from that.
We might, yeah.
Yeah, but that's solid. Okay.
Yeah, it's
So what's your deal?
My name is Shanling Li, and I'm in charge of the machine setup and the black hole simulation,
Hardware
and also
guy.
the quantum simulating. I'm doing the GPU part of the black hole simulations, and because of the scaling not as our expected, so we do not use this optimization. But it's actually a good try for. I don't write the GPU code before, so this time is the first time I try to use this.
Wow. Okay. So let's talk about your configuration a little bit.
Yeah.
Looks like you have, what?
4 nodes.
4 compute nodes?
Yeah, 4 compute nodes.
Okay.
And 2 GPU nodes.
Okay.
2
what's your-
GPU, 2 CPU nodes.
Okay. So what are you using for GPUs?
We are using for, we will introduce later the world model and the mystery problem.
But
also,
how many GPUs?
4
and what kind?
GPUs.
4
We're
GPUs.
using they provided the
two AMD.
Yeah, 2 AMD
Okay.
GPU and totally 4 GPUs on
So-
these clusters.
So do you have then 2 more AMD GPUs or NVIDIA GPUs?
No, we just AMD GPUs.
So 4 AMGs.
Yeah,
okay.
4 AMD
okay.
GPUs.
That'll be helpful because you can now devote them to all the tasks. And I would, what if you ran your cluster at full speed, all 4 GPUs, how many watts would it pull? It's going to get over 5,000 for sure.
We suggest that maybe about 5,500 watts will be. But actually, they run way lower than our expected. Like,
They'll idle way lower, but when they're running, they're lower too?
just the max performance of that, they spend less power than our expected.
Really?
Yeah.
Okay.
We expecting more, but actually they're really efficient.
You gotta be happy about that.
Yeah.
Yeah. But is it enough that you could add another node in maybe?
Because we think that our application will not use that much node, so we don't try to. We try to utilize this efficient, like we can run more, but with the time, like, we can run in a more application in time. Like,
Okay, but you've thought about it.
yeah.
Okay, good. Who's this guy?
Which is our 吉祥物.
What's your name?
My name is Ni Jiajun, and
Okay.
I'm working on embody world model and the second is mystery.
Okay. So what is that one you're working on? How's it going so far? The N-body problem. The N-body. Yeah.
Okay. I'm trying to optimize the memory caching and try to use different parameters to speed up the
Sure.
performance.
Is it working? Is it working? Are you getting better performance?
Maybe a little.
Little. Okay. It's early. You have time. Yeah. Okay. Keep going on it.
My name is Li Junwei,
Hey.
and I'm working on the embodied world model and ICON.
Okay.
And for the embodied part, I'm mainly optimizing the kernel part of the code. Like there's some kernel, there is many tiny kernels, and it produces many CPU host to device copy, and we fuse the kernel together, so we can reduce the copy times. And for ICON, we got some configuration flags from 学长姐from our mentor, and so we can we use that configuration and build a very fast ICON binary.
Good. It sounds like everything's going well. The hardware's running well? Yeah? Right, get the microphone. Say it again.
We built it very fast. We done a setup.
You were early on the set.
Yeah. Just yesterday afternoon, I think, we are set up all the machines. Like,
That's early.
I think we are really efficient.
Is it scaling?
Yeah, it scaled really well.
Yeah.
Like, we have tested ICON on this cluster. They can scale about 2 nodes. 2 nodes for a really great performance. Even better, 2 times better than our own clusters. Yeah, so we think it's really great.
Okay. Well, good. Great start. Impressive. Good job. We will come back and talk to you again and see how we're doing tomorrow and the next day. So thank you for the time. Good job. Bye-bye. Daniel's here. Last day, last minute check-in. You've got a few hours left. How you doing? We're talking to Taiwan Tsing Hua University. How you doing?
Pretty good today.
Yeah?
Bit better than tomorrow than yesterday.
Yeah, but that was strategic. The LINPACK was strategy. So, understood.
Oh, you heard about our LINPACK strategy?
I came over and asked you 10 seconds after I saw it. Because I know your team, and I know there's a reason behind it. And it wasn't because you forgot how to do LINPACK. So anyway, all good. How about today?
Today we are mostly focusing on AMSS-NCKU, and we tested a few scaling options in the morning, and now we are starting to run the whole thing.
It's a long run though, isn't it?
Yes.
And somebody said that they're looking at probably a 6-hour run. Oh. That long? I wouldn't think
I don't think it's not. I don't think it's that long.
it better not be that long. Right?
We already finished the first test case,
Okay.
and it looked pretty similar to what we expected.
Okay. Good.
We used OMP and SIMD vectorization to optimize it because we think it scales better with larger grids.
Okay.
And the test case had a larger grid than the preliminary round. So
That's what has been pointed out by other teams. Wait a minute. These are a lot harder than the practice cases and the preliminaries. Yeah, that's how they do it.
Yeah.
But good. It sounds like you're in good position to finish strong. Feel good about it?
Not so confident yet, but
Okay.
okay. Yeah.
Okay. Well, thank you for taking the time. Okay. Good luck, and we'll see you in the judging room tomorrow. Yeah. Bye-bye.